Hi everyone, we're going to find the partial fraction decomposition of this problem here. We have a linear term, so I put a for the numerator to find that out. And we have an irreducible quadratic term here, so I put a linear equation on top of that. Both of these have to be proper rationals, and I put all the possibilities that if you compose them back, we get our least common denominator here. So we're going to get started, and first of all clear the fractions, and we're multiplying by our least common denominator, which is always this piece right here. So I'm going to cancel those two out, and I'm left with x squared plus 2x plus 3. Over here this cancels out with that one, so you're left with a times x squared plus 2x plus 4. And this cancels out with this one, so you're left with bx plus c times x plus 1. Now the first thing I'm going to do is let x equal -1, because I want to cancel this out. If I plug a -1 in here, that's going to be 0, and -1 plus 1 is 0. So that cancels all that out, and I can solve for a. So I'm going to let x equal -1 and plug that in. Everywhere there's x, I'm putting -1. And of course, again, if you plug in a -1 here, that cancels out. So I don't need to write that. So simplifying this side, we're going to get this equals 2, and all of this equals 3a. So our a equals 2 over 3. Now all I have to do is find a b and a c. So the next one I'm going to do is let x be 0. And then just plug in your 0 everywhere. So you get a times 0 squared plus 2 times 0 plus 4. And then we have plus b times 0 plus c times 0 plus 1. And again, the reason we chose 0 is because this gives us a 1 here. That makes it easier, because then you're just doing that. So this side here is going to be 3. These all cancel, so you get 4a. The b times 0 is just 0, so you have plus c. Now we know that a equals 2/3, so from the previous slide, so substitute that in for your a to find c. So this is going to be 3 minus 8/3 equals c, and that's going to equal, because it would be 9 over 3 minus 8/3 equals c, and so c equals 1/3. So we have c equals 1/3. Now we only have to find d. So if we let x equal 1, let's see. Well, let's see. We had the 1, so we're going to let x equal 1. Plug that in. Always want to choose a small number or something that gives you a 1. So everywhere there's x, I'm putting a 1. 1 plus 1. And then what happens here is this side's going to be 2 plus 3, 6. This all equals 7. And this is going to be a 2 here. So you're going to get 2b plus 2c. Now, we already know our A and C, so we're going to plug that in. 6 equals 7. And plug in your A, which is 2/3. And plug in your C. So again, A was 2/3. And C was 1/3. So let's clean this up. You get 6 equals 14/3 plus 2B plus 2/3. And these two equal 16/3. You get 6 minus 16/3 equals 2B. And divide everything by 3 or 2. You get 6 times 3 is 18, so that's 18 minus 16 over 3. Divide it by 2, which is just going to be 2 over 6, which you just multiply those two, and that's going to give you 1/3. And that equals your B. So now we have B equals 1/3. Now you can plug everything in. So we have that x squared plus 2x plus 3 divided by x plus 1 times x squared plus 2x plus 4 equals my A, which is 2/3, divided by x plus 1 plus 1/3 x plus 1/3 divided by x squared plus 2x plus 4. Now, usually when both of these, the B and C here, are equal, they kind of rewrite this to make it look a little better. They pull out the 1/3, and that would be x plus 1. It just looks a little bit better. So just so you know, they just did the greatest common factor there, or the highest common factor. All right, that's all. Thank you. Have a nice day. Bye-bye.